Our next video is about multiplying and dividing rational expressions. So just to kind of review, don't forget a rational expression is an expression that involves a fraction. So if you're really good at multiplying and dividing fractions, then this will be really easy for you, maybe. If you're not so good at them, I'm going to quickly review a few things. So let's start by multiplying, and actually I'll write the directions down. So when I ask you to multiply, I'm going to ask you to find the product. So for these, the first one I'm going to give you is review of elementary school. And we have 4 over 5, or 4 over 6 times 9 over 5. There are two ways to do this. You either have the option of multiplying across, and you get 36 over 30. Then you would reduce it by dividing both of these by 6. Or the easier way to do it is to cross cancel. And the 6 and the 9 can cross cancel and change to 2 to 3. And also the 4 and the 2 can cross cancel and change to 2 and 1. So in the end you would get 6 over 5 also. I don't really care which way you do these. You'll find the second one is a lot less complicated because your numbers aren't going to be as big, but it's really your decision how you want to do them. So then let's go ahead and do one that involves variables. So I have 3x to the 4th over 4x to the 3rd times 2x to the 2nd over 5x. So I would recommend you start by cross-canceling the 2 and the 4. The other thing that you can do is you can try to simplify your exponents, but in this case it's really up to you. I actually don't recommend trying to simplify them because a lot of times people try to simplify the wrong things. So in our numerator, we're going to do our numbers and our variables separate. So first of all, for our numbers, we have 3 times 1, which is just going to give us 3. In the denominator with our numbers, we just have 2 times 10, or 2 times 5, which gives us 10. The next thing we have is our variables. Remember, when you are multiplying variables that have exponents and they have the same base, what you're going to do is you're going to keep the base the same, it's still x, and you are going to add your exponents. So we add the 4 plus 2, we get 6. For denominator, I'm going to put a 1 with the x, and now I'm going to add my exponents there, so I get 4. From there, we're not done yet. If you have variables in both your numerator and denominator, you do have to reduce. The 3 over 10 doesn't change. However, the x to the 6th over x to the 4th, there's a few ways to do it. The easy but long way would be to rewrite x to the 6th over x to the 4th as x times x times x times x times x times x 6 times. Do the same thing 4 times for your denominator. Cross out the things that you have in common, and you're left with 2 x's, so that gives you x to the 2nd. That's the long way. The short way to do it is just to subtract your exponents. Since you started subtracting with 6 minus 4, you started subtracting with a 6, what you have left over is going to go on the top of the fraction, the numerator, and you're going to be left with x to the 2nd. I don't care which way you do it, just do whatever way works the best for you. Okay, for the next problem, I would like you to pause and try it on your own, please. So for this one, there's a few ways to do it. I'm going to start by reducing anything I can. So the first thing I'm going to reduce is this 6 and this 3, which I can change to 2 and 1. So then from there, I am going to multiply straight across. The numerator I get 2 times 2, which is 4. The denominator I get 5 times 1, which is just going to give me 5. For my exponents, I am going to get x to the 6th in the numerator, and I'm going to get x to the 5th in the denominator. Don't forget that you are going to be adding your exponents. The next thing I'm going to do is I keep the 4 and the 5 where they are. They're reduced completely. I am going to do whatever method works best for you. I'm just going to subtract the exponents in my head, and I'm left with x to the 1st. So in the end, I just get 4 times x over 5. So the last part of this was sort of review from our sections on exponents. The next part we're going to do is going to be new stuff. So for my first example, I have 2x plus 2 over x plus 3 times x minus 1 times x plus 3 over x plus 1. So what you're going to do whenever you have something like this, you're always going to start by factoring. You're always going to factor first. In fact, everything in this chapter, you are going to be factoring first pretty much. So there's the previous section you factor, this section you factor, the next one you're going to also be factoring everything that you can. So first thing, the only thing actually, luckily my denominator on the first term is already factored. The numerator is not, however. I can factor out a GCF of the 2x plus 2. That gives me 2 times the quantity x plus 1. My denominator is x plus 3 times x minus 1. I have this whole thing times x plus 3 over x plus 1. So now, I always like to put parentheses here. You don't have to, but I think it's nice. Now you can actually cross cancel on this problem. So you can cross out the x plus 3 and the other x plus 3. You can cross out the x plus 1 and the other x plus 1. Now everything that's left over is just going to be your final answer. I have a 2 left over and I have an x minus 1 left over. I can't do anything more. This is my answer. So right now I'd like you to please pause and try these ones on your own. As with the previous problem, your first step is going to be to factor everything you possibly can. Luckily in number 5, and also a little bit in 6, but mostly in 5, everything's factored out already for you, which is really nice. So the only thing that's not factored is that 5x minus 15. For that, you can factor out your GCF, which is 5. You get x minus 3 left over. You also can now simplify some stuff by cross-canceling. So I can cross-cancel my x plus 2 and my x plus 2. Another thing you may or may not have done, but now you know that you can do it, is you can actually cancel things out that are right one above the other. So x minus 3 and x minus 3 can cancel each other out. So from there, there's actually nothing else left that you need to cancel, and you're done with this. All you're going to do is rewrite what you have left over. So I'm going to multiply straight across in my numerator. I'm left with 5 times x plus 1. My denominator, all I have left over is 2 times x plus 8. So now, if you, on the previous problem, forgot to cross out the x minus 3 for both of them, that is actually completely fine, because then you would be able to do it right here. So you would still get the final answer in the end. So if you notice that you forgot something, that's fine. Don't worry about it. Also, I don't recommend that you distribute the 5 and the 2. You can. I wouldn't mark off if you did, but I see more people making mistakes just by doing that step, and it's not necessary. So for number 6, I don't have to do anything to the second term, but the first term I do have to factor. X squared minus 25 is a difference of squares, which means I can write it as x plus 5 times x minus 5. 2x plus 10 has a GCF, which is 2, and I can factor that out and get 2 times x plus 10. I'm going to put parentheses around the x minus 3 and the x minus 5. And now I'm going to go through and cross things out. So the x minus 5 and the x minus 5 cancel. The x plus 5 and the x plus 5 cancel. All that's left over in the numerator is x minus 3. All that's left over in the denominator is 2. So this is my final answer. So the second half of this is going to be about dividing. And when I ask you to divide, we're going to ask you to find the quotient. So my first one, I'm just going to give you a very basic fraction one that you probably got when you were in 5th grade. At least I hope so. So the first one we have is 2/3 divided by 1/6. So just to remind you, the way that you solve these is you take the reciprocal of the divisor, which is the second number, and then you're going to multiply. So I'm going to take the reciprocal of the 1/6, which gives me 6/1. Now I'm going to change it to multiplication, and that's all I really need to do on that. You can cross cancel from there. The final answer that you get is 4/1, or just 4. So hopefully that was easy. We're now going to go on to a few that are a little harder. So let's say, actually I'll give you one that's a little bit more basic, and then we'll do some that are a little harder. So the first thing that you always do on these, same as the previous stuff, is you're always going to factor first. Okay, so here's my first example. All you really need to do is take the reciprocal of the second thing. Do not multiply anything. Otherwise, you are going to be in a world of hurt because it will take you forever. And in addition to taking you forever, it will give you the wrong answer, which is the worst thing. So all we change right now is we change the second thing. The divisor is now going to be multiplied by its reciprocal. So we now have x plus 5 over x minus 3. From there, you're going to cross-cancel anything that you can. So I can cross-cancel my x minus 3 and my x minus 3. I can cross-cancel my x plus 4s, or I can simplify those out. And I end up getting x plus 5 over x plus 8. And that's all I have left. So our last problem of the day looks really, really hard and intimidating, but actually it's not so bad. If you feel like you can do it, go ahead and give it a try on your own and pause it. So what you're going to do for this is you are going to, there's two things you can do. You can either factor everything first, or you can take the reciprocal first and then factor. Both will give you the same answer. I am going to factor everything first, but if you took the reciprocal and then you factored, you'll get the same thing. So when I factor it, first thing I have, I am going to come up with the two numbers that multiply to 24 and add to 5. The ones that I'm going to want are going to be positive 8 and negative 3. Next thing I do, same thing down here, I get two numbers that multiply to 8, add to 9, that gives me x plus 3, x plus 1, x plus 8. And next thing I'm going to do is x squared minus 9 is a difference of squares, so I get x plus 3, x minus 3. 6x minus 18, I have a GCF in there of 6. I can factor that out and get x minus 3. And all I'm going to do on the next step is just take the reciprocal of my divisor. Actually, a lot of people combine those the two first steps into one. I don't care if you do. Just do whatever works best for you. You'll find it works faster if you can just skip straight from the first step to the one I'm on right now. So then all you do from here is the fun part. You're going to go through and simplify anything out that you can. So what I can do is I can cross-cancel my x minus 3, and I can either cancel actually diagonally or above. It doesn't matter which one. Unfortunately, I can only do it once, though. I can also simplify the x plus 8s, and I have an x minus 3 and an x plus 3. Unfortunately, I can't do anything with those. I'm just going to leave them. So all I'm left with is 6 times x minus 3 over x plus 1 times x plus 3, and that's my answer.